You need to explain how a securely designed network uses a variety of technologies. Those technologies are the topic of this discussion.
You're watching IT Pro TV.
Hello, ladies and gentlemen. Thank you for tuning in to another great episode of CySA Plus. That's right, we are talking network architecture and segmentation. And Dan, I know we've got a lot of things to talk about here. So let's start out at the bottom of the OSI model, and let's just talk about physical. And I just said OSI because, well, I know that's the bottom of the OSI model.
Interestingly enough, we are going to talk physical in two different areas. We're going to talk it in network architecture, which is where we're going to start, right? And then when we get into segmentation, we're going to talk about it there. And that's where your OSI model really comes in. But here in network architecture, what they're talking about, what they're trying to allude to, is the idea of physical controls to your network devices. Right? And that could, I'm glad that you were actually confused by that, because when I started looking at the objectives, I was like, wait, hold on, there's physical twice here. I see what you did there. I see what
It's a transcendent thought process, right? There's multiple planes of physical.
Is anyone ever physical, really? Right. So in this instance, when we're talking about that physical network, and we get into that under network architecture, what we're talking about is how do we secure the devices that run our network physically, right? And really this boils down to, it's a type of segmentation, right? Which is why we're going to talk about it there, which is great. But we're going to need to wrap it with some security, right? It's going to need some guards, guns, gates, locks, cameras. We don't want to put those things out in the wild where anybody could just walk up and go, what's this do? Is that bad? Because it's not plugged in anymore. Doesn't seem to be on either. I'm gonna leave, right? Something we would like to avoid. Now that would obviously be an accidental outage, but it's an outage we would want to avoid nonetheless, right? We really want to avoid people walking up to something like a switch and plugging in a laptop, and then now they have access to the network. So a securely designed network is going to have some level of physical security wrapped around it when it comes down to the moving parts, right? So just keep that in mind. And then if you have a segmented network, as we get into segmenting, we'll talk about how we connect those things together, even though they are literally physically separated. How do we get them to talk, and what do we do with that?
All right, so I kind of joked around when I said, there are multiple planes of existence in physical. Now, let's go ahead and actually talk about something that has multiple levels. Let's talk about something known as software-defined networking. And I know that this is an interesting topic that some people might not really understand. So can you help us with maybe the broader definition and then go into the specifics on it?
Yeah, let's talk about SDN really quickly. And what do we mean by software-defined network? If you think of how much orchestration in virtualized environments, cloud environments, have really made things very easy to, well, I say easy, it's more consistent. Now, I think that's a better term for it. It's more consistent. When we're able to programmatically engage in some sort of activity, like defining a server or defining a network, then we have we're less likely to have an error. And that's what we want to avoid. People, when they have to manually configure things, typically something will distract them, and there will be errors involved with that, misconfigurations that could lead to some form of access or a vulnerability, a weakness to our system. A good way to avoid that is by going that SDN route, and it can help us out. So that's what it's meant to do. Maybe it's meant to be able to allow us to program our network. Now, I wanted to give you guys some really good information about this, so I got a couple of things that you're going to want to know about this stuff. It's centralized network management, right? That's the idea. But let's move into the planes. There are 3 different planes you want to be aware of. There's going to be the control plane, right? And these are basically network functions, okay? Control plane controls how traffic should be prioritized and secured, and it controls where the traffic should be switched. That's the control plane, okay? The data plane, next plane, controls actual switching and routing. So the data that's actually being moved, that's being controlled by the data plane. And this is where you would implement other security controls like ACLs, access control lists. Then there's the management plane, which is where you monitor traffic and network status. So these are the basic major components of software-defined networking. A couple other pieces of terminology that you'll need to be aware of. Northbound and southbound. You might see those and it could be confusing. So I want to get you on top on that. But Wes, you have a question?
Yeah, so my question is, this has always been a little confusing to me as well, and this is the communication between these layers, right?
And it's confusing.
It is, and I think about, so for instance, when we talk about the OSI model, which is assumed knowledge, right? At this point, is that when we say, oh, the network layer talks to the data link layer, and the data link layer talks to the network layer, right? We're talking about that intercommunication between these theoretical layers here. When you say northbound and southbound interface, is that what you're talking about? How they communicate with one another?
It is. It's the interfaces that communicates within different parts of the architecture of the SDN.
Okay, yeah.
Okay,
yeah.
so a northbound interface is between the SDN application and the SDN controller, right? So an SDN controller, that's where you do all the, I want to set these things like this, and it controls that, and the applications will sit on the devices, right? Then there's the southbound, which is the interface between the SDN controller and the SDN appliances, which would be the actual routers and switches that are SDN compliance, and that would give you that situation between them, the controller and those appliances themselves. So hopefully that, again, you don't have to be an SDN master, you don't have to be able to spin this stuff up. I did find a really cool piece of software to kind of help you out with this. So let's jump into my computer really quickly. It's called Mininets, and to download this, if you got a Ubuntu box, it's probably the same if you're running in some sort of Red Hat variant. Use Yum or apt, depending on your version. But if you install it, I just did an apt search for Mininet to see if there was a package. And lo and behold, there it was. So I just had to do an apt install and I was good to go. And now I can sudo mn and put in my password. And you'll notice it did a few things. It said no default OpenFlow controller found. OpenFlow is the open source connectivity for SDN. I do have an OpenFlow controller, just don't have it running. Found for the default switch. Falling back to OVS Bridge, creating a network. Cool, adding controllers, adding hosts. So added 2 hosts, H1 and H2, added 1 switch, added links from those hosts to that switch. It created a software-defined network for me that I can now use with my OpenFlow connector or controller of choice. I have one installed, and you can do this. You can do like H1, ping, H2, and you can see it's pinging. And it has an IP address, 10.0.0.2. That's not my local network. That's that software-defined network. Control-C that. Exit out of there. The controller I got was cd/opt. I think it's installed in opt. Yeah, onos. cd onos. And cd bin. And there you go. This was the onos service. And this is the controller. If I run this controller, I should be able to attach to those devices, and I would be able to configure and work with them and create that whole software-defined network using these devices. But that's the basic idea of SDN. Hopefully that clears up some of the mud on how it works. Again, you don't have to be amazing at this stuff, but you do have to understand the underlying basic concepts.
In one of our other episodes, Dan, we talked about different cloud models, right? And one of those cloud models was something known as a private cloud, and that required an extensive amount of infrastructure that you have to purchase and you have to maintain. Now, Dan, we do have a technology that allows us kind of to, the ability to have a private cloud, but we can have it on a public cloud. Boy, this sounds like Inception.
Yeah, how does that work? Right? Yeah, but you're absolutely right. These are virtual private clouds, VPCs, as we like to call them. And just about any of your cloud providers are going to have some form of this available. But basically, I'm saying, you know what? I want to create my own network, but I want to do it inside of the cloud. Okay, cool. I'm an AWS person. That's what's been available to me, and that's what I've used historically. So that's where I went. If you jump on my computer, I've logged into my actual AWS console, and there are the VPC resources. So you can see, like right here, I can come here and create a VPC. I've got subnets, routing tables, internet gateways, DHCP options, elastic IPs, security groups, ACLs, right? NAT gateways, all the wonderful stuff that we normally use inside of networking, all right here. And I can create those subnetted, segmented areas right inside the cloud. So I can put servers over here in their own VPC, and I can put application stuff over here, right? I can do all that stuff right here inside the cloud. So I just want to kind of give you an idea of what that looks like right here. So if I wanted to go into VPCs It'll show me some VPC information, the status that it's available, some of the IP address. I'm not going to go crazy with that. Some of the options that are set. So I can come in here and configure a new one, or I got create VPC here. Easy peasy lemon squeezy. It's all inside of my virtualized cloud environments, and I can spin those up. And remember, that's what networking is all about, or at least secure networking is being able to use the technologies that we're employing or we want to employ, or maybe would be a better option for us for our environment for security. So maybe pushing my network into the cloud would be a better idea than using physical hardware. I don't then have to manage all that hardware. I don't have to worry about updates and all that stuff. That's being done by Amazon. That's what they're providing for me as a service. All I need to do is make sure that anything that I configure is configured correctly and secured. I'm just worried about that at that point in time. So it takes some of that administrative burden off me security-wise to jump into the cloud. So maybe it's an option you want to go with.
Now, when it comes to secure network architecture, Dan, one of the things I know that it isn't so secure is any public network, which brings us really to our next topic. Can you tell me a little bit about VPNs?
Yeah, VPNs definitely solve that little bit of problem because I don't know about you, but I don't like being confined. I don't like boundaries. Borders, not my friend, right? So I like to go wherever I like to go and still be able to access my network. But and you can probably see that could be a security issue, and that's where VPNs come into play to try to help us with that. And they do a pretty good job of it. Really simply, they create a tunnel through public infrastructure so that we can access point-to-points our actual networks, our private networks, right? Now, typically, they will also encase that information and that's transmitted data in some form of encryption, that's good, right? Security, we like security. It's a good thing. But there are some cons to that. While it does give us great access from wherever we like to go, if we use some form of weak authentication, maybe a weak password, or if you're using some sort of weaker encryption protocol, you might have to worry about that. That is something that we will need to deal with. But as a security solution in most networks, you're going to find VPNs because it does allow you to migrate out beyond the borders of your walls and still gain network access via those VPNs. So we like them. We just got to make sure we understand the possible cons to using them so we can make sure we don't fall in those traps.
And that's where some of that assumed knowledge, right, does come in at a CySA Plus level, because you have to understand, why would I implement something like the layer 2 tunneling protocol over the point-to-point tunneling protocol that's been around since, 92? Chances are the older protocol isn't quite as secure. Dan, one of the things that, we can do here on premise within our networks is we can set up infrastructure if we want to test applications out, right? Mm-hmm. Very specific configuration helps for that one application. That's a lot of heavy lift. So tell me a little bit about this newer service, where, unlike the three services, we talk about IaaS, SaaS, PaaS. Tell me about function as a service. Where does that fit in?
Yeah, so function as a service is really cool. I actually, I think this is a very neat type of technology, or this is also known as serverless, right? So if you see serverless, think function as a service. And what basically is going on here is that instead of having to build this infrastructure, right, that has a server with an operating system, and then of course the technologies needed to run some form of code for an application, I just say, you know what, I just want to create a function for an application. And when I need to do that function, my application calls it, and my cloud provider delivers it to me and gives me access to it, right? I don't have to worry about operating system. I don't have to worry about technologies. I don't have to worry about updates. I don't have to worry about anything. The only thing I need to worry about when it comes to security is making sure that that function doesn't do anything stupid when it comes to my application and giving out any kind of sensitive information or data exposure, that kind of thing, right? So that's really what we're talking about when it comes to function as a service or serverless architecture. I'm removing the servers from being a part of the puzzle, if that makes sense, and I'm just going with what I need, which is the function that it provided me for my application. And hopefully you can see where the security would come into play with that, where since it kind of just spins this up, does what it needs, and then you're done. It's over. Now I'm just sitting with my focus on making sure that that function runs securely and not everything else. So it takes a lot of the lift off of us. I think this is the wave of the future, honestly.
I will tell you, there's a lot of things that cloud has innovated, a lot of things that has made it easier, but I wouldn't have thought 15 years ago that on my resume I could say, what kind of administrator are you? I'm a serverless administrator, and they would have hired me. You know, I don't mess with servers. That's right.
That's old.
But I mean, it does, you know, kind of lend itself to what it's doing here.
Yeah.
You don't have to manage the infrastructure behind it. You just pull these things down. They're ready to go. They have the application environments that you need to run and work with. Now, that is a lot about our network architecture. One of the things that you mentioned is that we have to get into, and this brings us back to the second inception of physical, right?
Yeah.
Is network segmentation, right?
Yeah, let's go right into that good segmentation, which we've, you know, really, Wes, I think you made this point before, is that we're going to see a lot of that cross bleed, right? Segmentation, some of the things we talked about could be construed as segmentation in a way, shape, or form, and that's fine. But for the exam, they call that out underneath network architectures, right? And segmentations are going to be, how do we separate out that data, right? Because basically, network segmentation is meant as a security function. Why? I don't need HR data on my IT network on a day-to-day basis. So there's no reason to let them cross-pollinate, because it just opens things up and slows things down, right? So a better method is to say, you know what, I'm going to take Wes and his HR department, and I'm going to give them their own little network. And I'm going to take me and my IT department, I'm going to give us our own little network. And only when we need to talk to each other are we going to cross those boundaries. If we don't, then we're going to stay separate, right? Wes, you have something?
Yeah, so, you know, let me see if I can help set up a scenario here and tell me if segmentation would play to this, right? I've got a legacy system. Let's just say, and we're not picking on Windows systems here, but let's say that we've got a line of business software that we've spent $150,000 on, and it's running on Windows 7, and we can't get any updates for it, right? Windows 7, we're filming this in the end of April 2020. January of 2020 is when Windows 7 is no longer supported.
I just had a heart attack.
Yeah, exactly.
What kind of network are you talking about?
That's right. So I've got a massive system that I cannot get updated, or maybe an embedded system, and we can't get vendor updates for it. What can we do when it comes to segmentation?
Yeah, great question. And basically, we're talking, most of these systems are going to be air gapped.
Air gapped,
right?
yes. Okay.
Where we're not going to connect them to anything. That is going to be that physical. And then you're going to have those guards, and gates around the thing, right? So just be aware that that physical segmentation is still a thing that we do, okay? Otherwise, this would just be topologically, where I've got a switch network. One network is over here, one network is over there, and they're going to use a router or something to connect to each other. That's typically how that thing would go down physically. So you got the, what's the word for that? Logical way to physically disconnect them or connect them. And of course, the actual physical way to go, shapa, take the chopping knife. There you go. I like that network. No one touches this one. This one's on lockdown. That's how we like it. So there you go. That's what we're talking about when it comes to physical.
Now we're gonna we're gonna blend the lines here between physical and logical, which we know is virtual. Let's think about it. You're in your data center right now. You see the big bundle of Ethernet cables coming back, and it is hooked up to a 48-port switch. That's physical connections, but we need a logical way to separate those connections for security reasons, and that's where something like VLANs come in. Right?
Yeah, VLANs are, man, we just love VLANs. They're great. They're phenomenal because I can take that high port density switch that I bought from Cisco or whomever, and I can separate them into their own little networks. And doing that very thing we were talking about with that segmentation. To say, okay, well now Wes is, even though we're plugged into the same device, I still can get some separation, right? And I can do that with VLANs. I actually jumped into Practice Labs because they have, if you're an IT Pro TV member, you jump into Practice Labs. I just grabbed a Cisco lab for switches, had a switch available. We'll get logged into it here really quickly. And let's see here, and I think it's show, if I can remember my Cisco commands, show VLAN, I believe. And there it goes. And you can see I've got default VLAN number 1. I created a VLAN called VLAN 200, which is right here. I put the fast Ethernet port in there, port 1. But I'm able to grab these ports. You can see the ports are over here listed out. I'm able to grab these ports, put them into separate VLANs, and then guess what happens? The switch goes, that VLAN and with those ports that are in that VLAN, they don't talk to this VLAN with those ports that are in that VLAN unless you got some sort of layer 3 device. So you're going to need routing functionality in there. I have now separated those out. I've segmented the network, but I've done it logically inside of the software instead of having to buy multiple switches and do all the cabling that's involved in that. I can grab one highly dense port density switch, plug everything into it, and logically separate it using VLANs. And if it's got layer 3 functionality, I can even do the routing inside of it as well. Otherwise, I would need to grab a router and do that. There's also trunking and everything that involves. So if I wanted to layer switches, grab more switches, put them together, say these 3 ports on this switch and those 4 ports on that switch are on the same VLAN. And then there's domains and all the other great stuff to help you manage this stuff. But ultimately, at the end of the day, this is the basics of creating VLANs and working with VLANs. If you want to create a VLAN, it's pretty simple. You just, I think you just say VLAN like 300, or it's not VAN, it's VLAN, and it's not LAN. VLAN, Daniel. There you go. Incomplete command, that's right, 300. And, what am I doing? Oh, config. T. I have not played with routers in a blue moon. It's been so long. Not routers, just switches. My Cisco stuff is getting rusty here. Then VLAN 300. And there you go. I think if I did VLAN, I think if do show VLAN should give me that 300. Hopefully. I think I'm doing everything right. Sometimes you gotta VLAN 300. And now do show VLAN. If I can remember how to do this. There it goes. Yay! And then I can add ports and everything. So it's pretty straightforward. It's pretty simple, but it gives us a lot of functionality.
All right, I got a lot of servers, a lot of services on my network, right? And I love being able to do remote administration. So I do remote administration on my workstation. I do remote administration on my laptop, maybe on my home network. Maybe, oh man, I love it. I can work from home. That's important right now. I've got this tablet. I can actually do this, right? You're probably seeing a little bit of the risk that's associated with having all these devices that have access to your important infrastructure. Dan, tell me how maybe a jump box would help us out on this one.
Yeah, so jump boxes are great. Sometimes they're called saws or like administrative workstations. So what we're going to do is we're going to create a dedicated machine, and that is the machine that accesses all the administrative functionality for like servers, right? Maybe even things like routers. And we're going to create access control lists to make sure that no one can contact these things directly. You have to go through the jump box to make some sort of connectivity to do administrative functions. And that narrows down the scope of attack for those devices. Okay, so really simply, let's see here. I'm in Kali Linux. Let's jump in here. Show you what I'm talking about. I'm in Kali Linux. I'm going to SSH as D Lowry into 10.10.10.136. Actually, 130. Was it 136? Was it 136? Yeah, that was it. Bing. We're going to try to get this done. I'm trying to access this thing, but nothing's happening, right? What's going on here? Well, I have an access control list via a firewall, the IP tables firewall, on that device saying, block everybody by default except this one machine. So if I want to access this machine that I'm trying to do right now, I need to be performing that function from that jump box. All right, so I'll just Control C this, and this time I'll try to go into here and I'll say, put my password in. There we go. And now I've logged into that machine. Now that I'm in there, I can SSH. I think the username is Mininet because it's my Mininet box. And it is 10.10.10.136. There we go. Now this does take a second. I don't know why this box is slow, but it will eventually give us a prompt here for our password. Once I get that, that lets me know that I have successfully connected. And there it is right there. I put the password in. And now you can see I'm on that box, host name. There you go. I have used prod1 as a bastion host for gaining administrative functionality and access into that Mininet server. So that's typically, it's a very simplistic way of setting this up, but it does work and it can be highly effective at stopping people from pivoting from one machine into another, specifically into your more sensitive areas of your network.
All right, ladies and gentlemen. Well, we talked a lot about different technologies inside of this episode. You got to see about network architecture and segmentation. And remember, that's important on the exam to be able to explain how a securely designed network utilizes these technologies. So if you're given a scenario, you can apply the appropriate security solution. We got a lot more to come when it comes to CySA Plus, but not enough episode in this time.
Not enough episode.
Let's try that again. We don't have enough time in this episode, so we hope to see you soon.
Thank you for watching IT Pro TV.